Hi everyone, I'm Harris.
Hi guys, I'm Danny.
Yeah, and I'm the founder of DevosHub, and today we are here in our R&D lab, where we actually developed our project we want to talk today about. Let me just briefly introduce myself and my background. I am a designer, and as a designer I always need to have my laptop with me, and I'm carrying my laptop every day with me all the day. But besides the laptop, I always need to have a charger. And honestly, Max charger is pretty big and pretty heavy to carry around all the time. It became a burden. And then on the other hand, like, it has only one port, which, I mean, for the laptop is enough. But let's face it, like, all of us have at least two devices that once a day needs to be charged at the same time. So yeah, and I mean, you're probably wondering, oh, but there are a lot of other companies. They already have chargers that are smaller or whatever. This is one of the chargers, and then as you can see, like the difference is not that big. It's still heavy. And another thing that I found out, and then I checked comments in the comment section of all of those other companies in the industry. Everyone is complaining about one thing, that is they are not reliable enough, which we will talk about later.
Yep. And
how we solve that. So yeah, so basically I had this idea with my other founders, but we all have similar issues, and then we also saw that most of the people in the world are facing the same issues as us. So we said, okay, let's try to solve that. Like, there must be a way. So yeah, and then basically me as a designer, I started sketching. I had these ideas in my head, how it can look, like what are the issues, and then these are the primary designs. As you can see here, these are all the situations that we at least at some point in our life come across. Like, either it is too big to fit in the laptop bag, or either it is like just popping out of the wall one big chunk of the brick. Like, it doesn't look good. And then I also tried, like, in different ways, like what are the things that I want to improve. So it is the design, like it is the compact design, like it needs to be small enough and then slim enough, and also needs to be versatile, like it needs to have at least two ports. For me, that was one of the most important parts. And the second thing is, like, it needs to be reliable. So the power, even though I know it sounds, if you are not engineer and I'm not engineer, it sounds a little bit, like, what does it mean in power? It has 70 watts, it has 140 watts, but actually the engineer, he will explain, it matters. And you can feel it, like, once you're charging your device. Right. All the day. And these are some initial sketches that I provided. And then me, as I don't have a technical background, like I don't know much about engineering part, but with good people around me, we actually solve these issues, how to put this in a compact design. And I think, Danny, maybe you can tell more about that. I don't want to dive into something that is not my area of expertise.
Yeah, so I'm in charge of project engineering, and when Harris bring us this $1 million idea, and we get our hands on that, we start by doing a couple sets of prototype. You can see it's very raw. It's a 3D printed, and we set out
It follows the design.
We follow design. So with this framework has a set, and then we'll start. Back then we started looking for the components and the solution for this product, because obviously it's not a small. Well, it's not easy product, because in the current industry, the common one, their power density is like 1.1 or 1 watts per cubic centimeters.
Yeah.
But we're talking about a product that's 1.42, and that's like 30 or 40%, comparing to the industry standard.
Yeah.
So, but I mean, with the help of some of the leading IC manufacturer. So we have the solution and the components to get our hands on the project. So, but along the way, when we design when we start doing the solution, and we found a problem that the components, the parts, they provided us is only intended for 75 watts, and the 75 watts is not for constant. It's just limited to short time outputs, and after a while, say like 10 minutes, it's gonna be dropped to 45 or even lower, like 30.
That's one of the testing videos we did just earlier, and then we recorded. So it's a lifetime. We will be posting that video along with this video as well.
Yeah, and I think that's very bad, because it would defeat the purpose of being ultra thin and powerful, and eventually it's just charger, like with that design, eventually it's just a charger that charges your phone, not your computer. So it would defeat this the whole purpose. So then we start to use our design and calculation to optimize the pairing components, and then eventually we make it into a 70 watts that's able to deliver 70 watt constant power. No overrating, no faking. So
no downgrading.
Yeah, no downgrading.
So as long as it is plugged in, it constantly outputs 70 watts.
Right. Yeah, this is the first very initial prototype we're talking about, and then with that, electrical parts is solved, and we have to look at the housing and the mechanical, because like this is a very small product. Very small product. Very small product. So we're talking about a product that's with this small, and it requires a high precision. So we take this to a very good quality tool factory, and then they sit down and do an analysis on the how the tooling is supposed to be, and how the injection will be. So they analysis the potential risk
issues.
Potential issue, and so we can avoid that.
How to resolve them in advance.
Yeah, exactly. So this is the very good. This is a very good quality factory that could help us. Yeah.
To resolve this issue.
Yeah. So with that, with electrical and mechanical soft, then we have to then we'll move to we move to the pilot production. So with very compact products, and we have to sit down with the factory and discuss. There might be potential risk, and so we have made a thorough analysis of that, and eventually the factory so are experienced enough to anticipate a lot of risk, and then we went to the production. Still, after the pilot production completed, we concluded some of the issue or the risk that we found during the pilot production, and we made change and made revision. Fortunately, not to the whole thing, but some improvement on the manufacturing process. So eventually, we come up with this product that it's a 70 watts, good 70 watts, and it also has this two USB-C ports that is smart enough to deliver to know what devices are connected to it. Like regular products, they will have a high power or low power configuration. Yes.
So you would need to get this port to if you want to get 70 watts, right? And then these two ports are only 25 or 30 watts, which doesn't make any sense.
Right.
Why do you have three different ports in the same charger?
Yep.
So this is one of the issues that we came across and we wanted to resolve. That was the thing, and then smart distribution is maybe
right. Like you know, for regular for regular chargers, the user have to look at very carefully, so they don't plug into they don't plug their computer to the low power port, and it will take forever to charge the laptop. And in order to solve this problem, and we have come up with this idea. It's not only the software, just line of coding, but we have to do another analog circuit to realize this function, because obviously the current IC manufacturer they don't have this solution, and they don't have this feature. So eventually, with this electrical and the software combination, and this automatic smart power distribution function is realized. So with this function, and basically the user can plug their laptop, cell phone, without even looking at the charger.
Yeah.
So when the cell phone is when the laptop is plugged in the port, it will give out the 45 watts, and when the cell phone is connected, it will give it a lower power, like 20 watts. But when two laptop connected, it will share
35.
Yeah, 35. Yes.
This was one of the things that really caught my attention. That the same charger, if you put two laptops, it's gonna be 35. If you put the laptop and the phone, it's gonna be 45 and the 20, right?
Right.
And then if you put two phones, it's gonna again split the regularly. So it has the power of recognizing what kind of device is plugged in. This is something we invent. Like it didn't exist in the market.
Yes. And the amazing thing about it is it's a real time and it's in time. So when user they unplug their phone and and plug another laptop on, and it will know automatically. This is something not existed in the market. So it's amazing about it.
I think this is the primary sketch of the motherboard, and then this is how the motherboard looks like. So right, you can see it's almost it's following the sketch. Like the sketch is almost the exact as it turns out to be. I think what is worth to mention is the chip.
Yeah.
And then the factory from.
Right, the
Navitas,
chip.
Right?
Yeah, the chip is from Navitas. So it's a leading IC manufacturer.
One of the best in the world, right?
Right. One of the best. And we also boost the performance of the chip, which eventually got us 70 watts.
Yeah. So I think basically these chips are used in those big chunky chargers, and then we actually redesigned the whole inside house of this charger, and then we put it in this kind of very small and compact design. So this was the prototype, right? And then this was the final design. So from the idea to the sketch to the CAD drawings to the so many testings with the factory, and then so many go back and forth resolving different kind of issues that we came across, of course, and then in the end we have the final product that is like so sleek and so compact. It literally fits like this in your hand. This was.
And another amazing part is about the product is efficiency at the 110 input voltage.
Yeah.
It got as high as 93%, where the market regular is gonna be just like 2 or 3% lower than us, and at the 220 input voltage, it's getting to 94%. So what that means is with that 3 to 4 percent
more.
of the user can have a save of 20 to 30% on the energy loss.
On the energy lost. So I mean, these are all the facts that really like made us to develop this product, because really we feel, all of us in the DevosHub, we really feel that everyone is going to benefit from this product, everyone. And yeah, and then here like you can see, we can just show you. Okay, so the product, like the product itself, you unfold it, right? You plug it in, and then you don't even need to look. Okay, I'm going to put this one in here, and then use this one for my phone. And then you can see here it's charging, and then I can use my charger for the laptop, and then plug it in my laptop, and then you can see here it's charging. So no worries, no issues, no need to think which port to get in, which port to get out. Like it's always, this is what I mean when I say a reliable, stable, compact design, and we are very proud of it. And I think that would be it, like, for this video.
Yeah.
Thank you.